so that we have plenty of time. So let me go ahead and get my whiteboard up here. Okay, so I think that you guys can see this. All right, can we see this? I think that we can. Okay. All right, so we're going to start with section 4.2a, and we're just going to go through this, and I want you guys to stop me and ask your questions just like normal. Okay, nothing's changed. And we'll see what happens. So in this section 4.2, there's a lot of stuff going on. And the first thing that really is going on is we are talking still about functions.
I don't think any of us can see what you're doing or see you.
Well, I haven't written anything yet. Can you see this writing?
Yes.
Okay, so you're not going to see me. I haven't, we're just doing whiteboard today because I have some stuff I want to write. But yeah, so I think we're good. Thank you, though. Okay, so the very first thing in this section is talking to us about linear functions. Linear function. And a linear function is just a function that can be written like this. F of x equals mx plus b. And doesn't this look kind of familiar to you guys? What's this look like, sort of? Anybody know? Okay. All right, so this reminds us of slope-intercept form from several days ago. And so in parentheses, we're going to say that the m is still the slope, and that 0, comma b is still the y-intercept. And so maybe it looks a little different because it's in function form, but we still know that. And so what's going to happen is the very first type of example that you're going to see in this section is going to say, hey, look, here's a function, f of x equals 3x plus 2, maybe. And maybe they're going to ask you to graph it. I can't remember. But they're going to say, hey, looking at this, you should be able to still remember the slope, and you should be able to still remember the y-intercept. And so from looking at just this example, what is my slope? 3. Thank you. And 3 over 1. And the y-intercept we know is going to be 0, comma b, so in this case 0, comma 2. Nothing is new here. Okay, this particular problem, the new thing is this. Instead of this being a y, it's now f of x. That's it. That is literally all. What are your thoughts on example 1? Okay. So then let's take a look at the next example. So example number 2 is going to be the same-ish, but it's going to look slightly different. They're going to give you this, f of negative 11 equals negative 9. And they're also going to tell you that the slope of the function f is 6. And the end goal, what we're trying to do, is it wants us to write a function that's in mx plus b form. Whatever I circle, I need it to look like this. That's what I need. Well, I definitely don't have that, but I have several pieces of that. And so in the past, didn't this used to be a y? Sure. And so it used to say y equals mx plus b. Well, I know lots of pieces. I know that the slope is 6, and I know the slope is represented with an m. And I know that this usually says f of x, but since it says negative 11, I know that x is negative 11. And we know that when we put an x value in and we do some evaluation and the number that pops back to us, we know that's the y. So I have an x, I have a y, and I have an m. And so what I can do is I can write y equals mx plus b. But instead of using all these letters, I can use actual numbers. So I'm going to write this out as negative 9 instead of y, equals sign, 6 instead of m, parenthesis, negative 11 instead of x, and then plus b. I'm writing this as a capital B because sometimes my lowercase b looks like a 6. And so what I'm going to try to do here is solve this equation and get b by itself. And then I'll have every single thing that I need to come back over here and write it as a function. And so in order for me to solve for b, I'm going to have to distribute. So I'm going to have negative 9 equals negative 66 plus b. And then the last thing I'm going to have to do here is add 66. And so I'm going to get that b equals a positive 57. And so now what I'm ready to do is I'm ready to go ahead and write my actual function. So I will have f of x equals the m value that they gave me is 6. We know that this x stays the same. And my b value that I just solved for is plus 57. And this is my final answer. This is my function instead of an equation. What are your thoughts on this process? Take a second, look over it, let me know. So I'm assuming that our silence means we're good. So let's do another one just to make sure, okay? Because this is the one that we sometimes struggle with. So let's do a new one. I also wanted to mention the notes that we're writing right now. I'm going to upload them in Blackboard here in just a bit. So if you don't feel like writing, or if you're a little behind or whatever, the notes will be available to you. Okay, so here we go with this next one. So I suppose this is number 3. We're going to find that f of 8 is equal to 1. And the slope of the function f is 5. And again, we are trying to get f of x to equal mx plus b. That's what we want our answer to look like. Well, of course, we don't know b. We know everything but b. And so we know that this is our x value. We know that this is our y value. We know that this is our m value. And so I'm going to write y equals mx plus b. And I'm going to replace everything that I can. And so y is 1, m is 5, x is 8, and then plus b. And again, I have to solve for b, just like I have been. And so I will have 1 equals 5 times 8 is 40 plus b. I will subtract 40 from both sides, and I will get b equals negative 39. Any questions so far? Okay. And so now I have everything that I need in order for me to write this as a function. So I'm going to put f of x instead of y. My m value that they give me is just a 5. I know that this x will stay x. And then I did all this work and I got b to be negative 39. So minus 39. And this is my total complete final answer. Done. Questions, problems on these two? Okay. So that's those are my linear functions. Not a lot of change, just a little bit of, evaluating here or there, but no big deal. Okay. And so now we are ready to then look at a quadratic function, which is going to look different and which is going to have different properties and which we're going to do different things with. And so here we go. So a quadratic function is a function that can be written like this. F of x equals ax, hold on, back it up. Ax squared plus bx plus c. That's what my quadratic function is going to look like. And we also know that the graph of any quadratic function is roughly this is a capital U. It's in quotes because it's not necessarily a letter. It just looks like that. Shaped curve that is known as a parabola. Parabola is important. We're going to use that word, and we're going to see that word, and we're going to see those types of U-shaped curves a lot. Any questions on the definition? Now, this should look familiar. We have seen equations in the past that were in the ax squared plus bx plus c form. Okay, we've done that in the past. And so the first thing that we are going to do is we're going to take a look at a very basic parabola just so we have an idea kind of what that's going to look like. And so if I give you, so there's our definition. If I give you the equation, or the function rather, f of x equals x squared. we're going to graph this thing. And this little guy is going to be the most basic parabola that we ever see. We're going to use them a lot. So we have to really get a good grip. And so in the past, in order for us to graph, we chose x values. We plug them in, and y values spit out of us. Well, we have no longer we don't talk about y anymore. We talk about f of x. And so in order for you to get a really good idea of what this looks like, I'm going to pick a lot of numbers. We don't always have to pick this many. I'm going to pick -3, -2, -1, 0, 1, 2, and 3, just so we have a good idea of what's happening. Since my function is just x squared, any of the x values that I choose, in order for me to find their actual function values, all I have to do is square them, which is going to be super easy. And so -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So now I have all these points. Okay, I have several of them, 7 of them? So I have 7 points that I can graph. And so I'm going to come over here, and I'm going to actually draw this out on a graph. And so I will graph all of these points, and you will see what the most basic shape of a parabola is going to look like. And so I will graph -3, 9. So I go left 3, up 9, so here. And then I will graph, actually, I'm going to graph this in a different color so that it's easier to differentiate. Just all this black. So then -2, 4, so 1, 2, 3, 4. -1, 1, 0, 0. +1, +1. +2, +4, and then +3, +9. And so here are all my dots. And so according to my definition, it's a U-shaped curve. So I don't want to make a straight line here. I want to make a nice fluid U curve, the best that I can. Okay? And again, when you're doing this in Hawks, you're going to have actual graphs, so it's going to look much better. All right, and so there's the very first parabola that we've ever graphed, x squared. Now, before I do anything else, excuse me, I had to yawn. What are your thoughts on this particular green graph? Any questions, any problems with how I got that? Okay, so a couple of things that we're going to be able to recognize just from this picture. The first one is this. We know that this is the point 0, 0. This is also known as the vertex. The vertex is not always 0, 0, but in this case it is. The definition of a vertex is the point where the graph changes directions. Changes direction. And so what that means is, if you were looking at this graph from left to right, like you typically read, you're going to see that, hey, you're going down, going down, going down. As soon as you hit this vertex, you stop going down, and now you're going up. So when we talk about changing direction, that's what I mean. This graph was going down, but then it started going up instead. So that's pretty cool. Now, another thing that we know from just looking at this graph is you can see that the vertex, again, it's not always going to be 0, 0. It happens to be 0, 0 here. If we could pick this graph up and fold it along this dotted yellow line, then what would happen are these 2 points would touch each other. And these 2 points would touch each other. And of course, these 2 points would touch each other. And the vertex, it would touch itself, so to speak. And so that particular line, this yellow dotted line, that is something that is called the axis of symmetry. Axis of symmetry. And this line is important because what this line does, it's a line passing through the vertex. And it cuts cuts the parabola into mirror images. So wow, we have a lot of information just from this picture. We know what the vertex is. We know it's where the graph is going to start changing direction. It will be easy for us to find the axis of symmetry. It's just a line that passes through the vertex and it cuts the parabola into mirror images. So again, if I could pick this graph up and I could fold it on this yellow line, all of these little dots would mirror each other. Okay, just imagine, put your hands up side by side and fold them. You will see how your fingers, of course, match each other perfectly. That's the same idea that this parabola is going to do. So take a second, look at this screen from start to finish. I give you the definition of what a quadratic function is. I tell you what it should look like. We look at the most basic one. We look at its vertex. We look at its axis of symmetry.
Don't erase that yet.
I will not. Are there any questions or problems on this page while we're writing? And keep in mind that these notes will be available online later today. As soon as I get them uploaded, they're already going to be there in case you missed something. So any questions, any problems right now? All right. Are we ready or do we need another second? Okay, I'm going to assume the silence means I can go. Is that true? Okay. All right, now, this guy was easy to graph. It was a nice, neat parabola. There was only one little piece. It was no big deal. Unfortunately for us, that's not always going to be the case, okay? And so the next couple of problems that we're going to do are going to look a little different. And so let me go ahead and get rid of this. We're going to have something, and this is going to be easier, I think. It's called vertex form. It's going to look like this. You're going to be given a function, and it's going to say f of x equals a times x minus h. That whole thing is squared, and there's going to be plus or minus k back there. I'm going to put the formula sheet in Blackboard later too, so you'll always have these formulas available to you. And so this particular function right here, this is vertex form. And so what's going to happen is we know several things from this. A couple people in my last class said, hey, this looks awfully familiar. It looks like we have that circle stuff. And I said, yeah, you're right. And so we know three things from just looking at this. The vertex of this particular parabola is going to be h comma k, just like the center of the circle. So that's not super new. And we also know that when we look at this, the minus sign is part of the problem, is part of the actual formula. So we're only going to be plucking out this h value. We're going to take this as its face value. So whatever we see right here, it's going to look like something, but we're going to write the opposite. Meaning, right now this looks like this says negative h, but we're taking it as a positive h. This looks like it says positive k, and we're leaving it like that. So we have to make sure that makes sense. Now, a couple of other things that we're going to know when it comes time to graph a parabola is if my a value is positive, my parabola is going to open upwards. So it'll look something like this. But if a is negative, well, if you had to guess, you would probably say that it's going to open, down, open downwards. So it will look something like this. So what our goal here is to take a function that's written out in vertex form, quickly and easily list the vertex, decide if it's opening up or down, and then move forward and actually graph that. So the next thing I'm going to do is actually write a function, and we're going to do the problem from start to finish. We're going to look at the function, we're going to pluck out that vertex, we're going to decide if it opens up or down, we are going to solve and find if there are any x-intercepts, we're going to find a few other points just in case there may not be any x-intercepts, and then lastly we're going to graph the whole darn thing. Okay? All right, so here we go. Let's do that from start to finish, and we'll see what you think about it. Maybe if I can get this thing to work. Okay, so here we go. If we're given f of x equals x minus 5, whole thing squared, minus 4. So this is my function. I'm going to do a lot of stuff to my function, okay? The first thing I want to do is find its vertex. And so luckily for me, it's already in vertex form. And so when I look inside these parentheses, this looks like a negative 5, but I'm always going to take the opposite. And so since this looks like a negative 5, what's going to happen is my vertex is actually going to be a positive 5. And then over here, I take this guy for face value. He's a negative 4, and so he's going to have to stay a negative 4. And so there's my vertex. No work, literally no work. I just looked at it. Questions on finding the vertex?
Why is it always the opposite?
Okay. The reason why it's always the opposite is because way back when I gave you the formula, this was just an h instead of an actual number. And we know that let me get another color here. This x and this subtraction sign are part of the formula. And so what's happening is this number, whatever it is, that's the number. I'm going to just color this in totally. That's the number that I am going to be replacing. This x and this minus sign are constant all the time. The number that's under this is what's going to change.
Okay, so if it was negative, then it would say +5.
That is true, yes.
Okay.
Okay, so let me get it back to its normal little state here. And we'll see one of those later on. Oops. Oh, man. I want that to be black. Okay, so we have the vertex. Any other questions right now on finding the vertex? All right, so the next thing that we need to do is we need to go through and we need to find some x-intercepts, if possible. Maybe there are, maybe there aren't. Okay, but that's what we got to try to figure out. And if you remember, the x-intercepts are points somewhere along the x-axis. That's what we're trying to find. Are there any points that cross the x-axis of this graph? Well, if you remember, we've already actually done this. So what we're going to have to do is we're going to have to take our function, which is x minus 5 whole thing squared minus 4. We're going to have to set it equal to 0 because that's where the x are found. And so from way, way back, we talked about this. If I have x squared, how many answers do I know I need to have?
2.
2. And so again, way back when we did this, we knew that if we needed 2 answers, we had to factor. Well, we can't factor yet. So the first thing we're going to have to do is get rid of the square by foiling. Okay, we cannot just go boom, boom. Nope, we can't do that. We actually have to FOIL the whole thing. We can't forget about our minus 4, and that's set equal to 0. So here I go foiling. So I'm going to have x squared minus 5x minus 5x plus 25. Don't forget our minus 4. All of that equals 0. Now, I want to combine my like terms. So these two guys are going to give me negative 10x, and these two numbers are going to give me plus 21, and that is still equal to 0. Now, finally, I'm ready to factor. Set my parentheses, I pop some x's in there, I say, okay, I need two numbers that are going to multiply together to give me a positive 21 while adding up to give me a negative 10. What do you think? What numbers am I going to be doing here? Well, it's going to be 7 and 3 because 7 times 3 is 21. And since I need the 10 to be negative, both of these guys are going to be negative. Well, if we remember way back, what that means is x minus 7 equals 0 or x minus 3 equals 0. And then over here, I would add 7 to both sides. And I would get, so I'm going to come over here, so I'm out of space. I'll get that x equals 7. But we know it's a point, not just a number. And so that's going to give me the 0.70. So there is one x-intercept. Well, at the same time, I know that in this case, x is going to be 3 from this guy. But again, I know I can't just leave it as a line, so I have to write it as a point. And so here are my x-intercepts, 7, 0, and 3, 0. So take a second, take that in. I'm going to rewrite it over here so that we can see it. What are your thoughts on finding the x-intercepts? Any questions, any problems right now? So we take the vertex form, and we list it all out, and then we do our foiling, and then we combine our like terms, and then we factor, and then we solve. So this whole area over here, that's not anything new. Okay, well, the next thing that we're going to have to do then, in order to graph this, is to find, and I'm going to get rid of some of this because I know it's getting messy, is to find two other points on the graph, because there's not always x-intercepts, and I cannot graph a parabola with just its vertex. And so I'm going to get rid of all of this work then, if we can do that, and we are going to find two other points that are also on this graph. That way I'll have several points so that when I go to graph this thing, it will be very accurate. And so I think we did this in the past somewhere along the line. I can't remember exactly where. But we have plugged numbers in and we've gotten results. So that's what we're going to do here. So we have said already that our vertex is 5, negative 4. So somewhere out there on my graph, 5, okay, so maybe it looks like this. And this is the number 5, and it's going to be opening like this. If I want to find two other points, it makes a lot of sense for me to choose something really close to 5. So what if I choose the number 4 and the number 6? Because 4 and 6 are the two closest numbers to 5. And so in order for me to choose my other points, I'm going to say, well, what if I let x equal 4? Well, what's going to happen is I'm going to bring my function down here. I'm going to put 4 in for x, and I'm going to evaluate this thing. And so 4 minus 5 is negative 1, and negative 1 squared is just positive 1, and 1 minus 4 is a negative 3. So if I let x equal 4, my y value is a negative 3. And just like that, I have another point. So I've taken care of 4. Well, let me say, what if x were to equal 6? Okay, same thing. I'm going to bring my function down. I'm going to let 6 be x. And I'm going to say, okay, well, 6 minus 5 is 1. And 1 squared is still just 1. And 1 minus 4 is again negative 3. So if I let x equal 6, I have another point, 6, negative 3. And so here are my two other points, 4, negative 3, and 6, negative 3. Okay, now let me pause there. What are your thoughts or what are your questions on finding these two other points? Anything at all? Okay. And so then what's going to happen is I'm going to get rid of all this stuff, and we're going to take the 5 points that we have, and we're actually going to graph this parabola, and we're going to see exactly what it looks like. Okay? And again, when you go to do this in Hawks, your graph is already going to be pre-populated, so you don't actually have to draw this out like I am. So here we go. So here will be my graph, and I need to get some dot or some tick marks on here. Okie dokie. And so the first thing I'm going to do, I'm going to use a different color so we can see it, is I'm going to graph the vertex, which is 5, negative 4. So I'm going to start the origin. Oh, and I didn't make my graph big enough. Hold on. I'm going to start the origin. Start my origin, and I am going to go to the right 5 and down 4. So 1, 2, 3, 4, 5, and then down 4. 1, 2, 3, 4. So here will be my vertex. And so then the next thing I'm going to do is I'm going to graph my x-intercepts, which are these 2 points. So 3, 0. So start the origin. I go to the right 3. And also 7, 0. 3, 4, 5, 6, 7. Okay. So got those. And lastly, I'm going to graph my 2 other points, which we got to be 4, negative 3, and 6, negative 3. And so I'm going to go over 4 to the right, and then I'm going to go down 3. And then I'm going to go over 6 to the right, and I'm going to go down 3. And so now you can kind of see that my parabola is starting to take shape. So I've graphed all 5 of my points. I already know that it's supposed to look like a U, so to speak. And so I'm going to start here at my vertex, and I'm going to come up like this. And then I'm going to come on the other side, and I'm going to come up like this. And now I have my parabola. And now I'm done. So take a minute and think about everything that we did. We found the vertex, we found the x-intercepts, we found 2 other points, and then we graphed it. Any questions or problems on this particular one from start to finish? Okay.
Will we always have just 5 points to graph?
No, we will not. Sometimes there will be an instance, which we're about to see in the next problem, where there's actually not going to be any x-intercepts. So in the next problem, we're only going to have the vertex and the 2 other points.
Okay.
Okay, but maybe to answer your question further, you're never going to need more than 5 points. How about that? I'm never going to say, oh, and find 14 extra points. No. Okay, so it's either going to be 5 points or essentially 3 points. Okay? All right, so let's take a look at a second one. And I already told you there wasn't going to be any x-intercepts, but let's pretend for just a second that we don't know that. Okay? So here's what the function is going to look like. It's going to look simple enough. H of x equals x minus 2 squared plus 8. Okay? And so, again, we need to find several things, and the first one being the vertex. And so I need to be able to look at this, and without having to do any work, I'm going to say, okay, what's my vertex? I look over here.
2, 8.
2, 8. Perfect. Okay, so vertex done. And so now I'm trying to find my x-intercepts. And again, we have to pretend like we don't know. I already told you there weren't going to be any. Okay? And so what happens is we say, okay, we take x minus 2 whole thing squared plus 8. We set it equal to 0. We FOIL to get rid of this. Then we factor, then we solve. And so I'm going to have x minus 2, x minus 2. Don't forget my plus 8. I do all of my FOILing. So I'm going to get x squared minus 2x plus 4. And then my plus 8, and that's equal to 0. Okay? And then I'm going to combine my like terms. So these 2 guys are going to give me negative 4x. These 2 guys are going to give me plus 12. And so then I set my factoring up, and then I say, okay, here I go. I need 2 numbers that are going to multiply to give me 12. And while they're multiplying to give me 12, they're going to add up to give me a negative 4. Well, here are my factors, like I taught you guys way back. There's no possible way on earth 1 and 12 is going to give me 4. And there's no possible way on earth that 3 and 4 are going to give me 4. So my best bet is if I can look at this 2 and this 6. Well, here's the problem. If I make this positive 2 and positive 6, they're going to add up to give me positive 8. So that's not going to work. So I can't have positives. So if I were to make each of these negative, and I had negative 2 and negative 6, well, they're multiplying to give me the positive 12, but they're going to add to give me a negative 8. Well, that's not going to work. And so if I make one positive and one negative, well, let's see what happens there. So maybe I make a positive 2 and a negative 6. Sure, it adds to give me a negative 4, but it multiplies to give me a negative 12. Well, shoot, that's not going to work. And so what's going to happen? Nothing. Okay, this doesn't factor. And so what happens is I say, oh, well, as soon as I realize that it doesn't factor, I can stop and I can come up here and I can just say that there are no x-intercepts. And so as soon as you hit a point where you can't factor, you get to stop and you get to say, oh man, there's no x-intercepts, so I'm done. All right, now, the whole reason why I'm asking us to find 2 other points is because sometimes there are no x-intercepts. And I cannot graph a parabola with just 1 point. I need something else. So before I erase this and we work on those 2 other points, are there any questions about the fact that there are no x-intercepts? Okay, so then let's get rid of this. Let's find those 2 other points, and then we'll be able to graph it, and then we'll be done with it. So again, we're going to look up at our vertex. We're going to say, okay, well, the vertex is 2, 8. And so it's going to make sense for us to choose numbers that are close to 2. And so how about 1 and 3? Because those are pretty darn close. And so if x were equal to 1, so if x equaled 1, then I would have 1 minus 2 squared plus 8. And so 1 minus 2 is negative 1, and negative 1 squared is 1, and 1 plus 8 is 9. And so I have the point 1, 9. And so here's one of those points, 1, 9. And then we already said, well, what if then x was equal to 3? And so I bring down my function, I put a 3 in the place of x, and I say, okay, well, 3 minus 2 is 1, and 1 squared is 1, and 1 plus 8 is, again, 9. And so I have the point 3, 9. And so now I have 3 points. I have the vertex and 2 other points, and really that's all I need. And so are there any questions on how I found these 2 other points before we move on? Okay. And then so what we're going to do is we're going to actually go ahead and we're going to graph this thing, and then we'll be done with it. And so let me get rid of this. And so we have our vertex, we have 2 other points, and that's all we're going to need in order to make our parabola. And so I will draw my graph. And so I will first graph my parabola's vertex, which is 2, 8. So I will go from the origin over 2 and up 8. So over 2, 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be here. And so there's my vertex. There's no x-intercept, so I don't have to worry about that. And then I will graph these 2 other points, which is 1, 9. So I start at the origin. I go over 1. I go up 9. So there's that one. And then I have 3, 9. I'm going to start at my origin. I'm going to go right 3, and I'm going to go up 9. And there we go. And so now we know, again, since this is a parabola, it's not straight like that. It's going to be curved. And so even though I only have 3 points, that's okay. I can still get a little bit of curvature going. And so I do that, and there's my parabola. And now I'm totally done. Now, what are your thoughts on this particular one? Any questions, any problems? Okay, cool. All right, now, it would be super great if every function, every quadratic function in the whole wide world looked like this, okay, but it doesn't. They're not always given to me in this vertex form. And so sometimes they're given to me just, plain, and I have to put them in vertex form. And so that's what we're going to look at next. So we're going to look at quadratic functions. And then we're going to go from a regular quadratic function to vertex form. Okay, because what's about to happen is we're going to have a quadratic function that looks like this. F of x equals a x squared plus bx plus c. Well, that doesn't help us at all. We need to put it in vertex form, which is a times x minus h squared plus k. So this is what we're going to do. And the method that we're going to use to do this is to complete the square. And so way back when we talked about this, and you guys hated me for it, and I said, I'm sorry, it comes back. Well, here it's back, okay? Now, once I complete the square, I'm going to be it's going to be easy for me to find the vertex, just like it was. It's going to be easy for me to find the x-intercept, just like I did. And it's going to be easy for me to find 2 other points. And so the new part that I have to really focus on is this completing the square. This stuff right here we just did in the past 2 problems, that's not going to change. Okay, so the difference here is I have to complete the square. So, any questions before we start? Because we're going to dive right in and we're going to tackle a problem from start to finish. Okay. So then let's do it. So here we go. So the problem I'm given is f of x equals x squared plus 8x plus 15. That's all I got. And so before I do anything, since this is a positive number out front, the one thing that I definitely know is that this thing is going to open up. So it's going to look something like that. I know that for sure. Other than that, I know nothing about this guy. Well, obviously that has to change. Okay? Now, we've already completed the square several times in other types of math problems that we've done, so to speak. But this one is going to be just a hair different. And so you got to make sure that what I'm about to write down, you're really watching, okay? So here we're going to go. We're going to come over here, and we're going to put x squared plus 8x. We're just going to set them side by side. We're going to leave a little bitty blank spot that we'll fill in a moment, and then we'll have our plus 15 out here just hanging out, okay? So here's my scratch work, just like always. I take my b value, I divide it by 2, I put in parentheses and I square it. And so my b value is 8, I divide 8 by 2, I get 4, I square 4, I get 16. And so now what's going to happen is the 16 that I get is positive, so I'm going to put a plus 16 right here. Excuse me. These 3 pieces are the pieces that I am mainly concerned with. These 3 pieces, this is what we had called our perfect square trinomial. Now here's the thing. In the past, we had an equal sign. Okay, and I'm not talking about this equal sign because this is my problem right here. In this problem, in the past, we had an equal sign. Maybe it was, equal to some number over here, something. I don't know. We don't have that anymore. We just have a standard function with no equal sign. And so what has to happen is this. Technically, I put a positive 16 right here. Well, the opposite of a positive 16 is going to be a negative 16. And so what has to happen is I have to come outside of my parentheses and I have to put a negative 16 out here. And the reason why I'm doing that is because a positive 16 and a negative 16 would cancel each other out. And if that were to happen, this x squared and this 8x and this 15 is exactly what I started with. And so technically, even though it looks like I'm changing my problem, the value is still going to be the same. And so what happens is, in order for me to combat this positive 16 that I've put in, I also have to tack on a negative 16 on the other side of my parentheses. Now, this guy right here, these 3 terms, this is what I'm going to factor quickly by looking in this box. I'm going to have x plus 4. This is a positive 4. It's being squared, so squared. Then these guys over here, these are just numbers. And when I add them up, I get a negative 1. And so now what has happened is by completing the square, I've gone from just my normal, regular quadratic function form, and I have put it into this vertex form. And so this is my vertex form. So that's the new part. That's the completing the square. What are your thoughts on that? Anybody have any questions? Anything they want to ask or tell me?
So will we always subtract the b value since there's no equal sign? We'll just like add it on the one side and then subtract it?
So yes, but also no. And I know that's a dumb answer, but you're right in saying that we're always going to have to cancel it out. Now in the next problem that we're about to do, you're going to notice something is a little different, and you're going to notice that we're not necessarily just subtracting. So if you will, bear with me through that next problem, but you're right, we're always going to have to take that into consideration, okay?
Okay.
All right, anything else for right now on this guy before we find everything else that we need to find? Okay, and so now what's going to happen is this stuff right here, I don't care about it anymore. This is what I care about. And so from just looking at this, what is my vertex? So this is a question someone asked me. Since this is a positive looking 4, what kind of 4 am I going to write as my vertex? Negative. And this guy right here, we take him for face value, and so he's going to stay a -1. And so I've gone, oops, sorry about that. I've gone from regular old quadratic function form. I completed the square. I put it in vertex form, and now I was able to find the vertex. Now I want to find the x-intercepts, just like I did in the last problem. Now, the cool thing about finding the x-intercept of a problem that was not given to me in vertex form is I don't have to go up here and do all this foiling and all this factoring, because technically it's been done for me. It's right there. And so what's really cool, and I know you're thinking I'm probably overusing the word cool, but it is, it's really neat. I don't have to do all that work. So what I get to do is I get to just say, hey, guess what? I'm going to take x squared plus 8x plus 15. I'm going to go ahead and set it directly to 0. I can quickly factor, and then I'll be able to solve, and it'll take way less longer. And so I'm going to need numbers that multiply to give me 15 and add to give me 8. And so I'm going to get 3 and 5. And I'm going to quickly solve this, and I'm going to say, hey, guess what? This is going to be the point -3, 0, and this is going to be the point -5, 0. And there are my x-intercepts. Questions on finding the x-intercepts? Okay. And then so I have my intercepts to be -3, 0, and -5, 0. Okay. And so now I need 2 other points. And so what I'm going to do is I'm going to look at my vertex. Yeah, I'm going to look at my vertex, and I have a -4 as my x value. Well, I've already used -3 and -5, so I want to pick some values that are still close, but I can't pick I can't pick -3 and -5 because I already picked those. And so what if I let x be -2? How about that? So if 2, -2 is right in here, and I'll have -2 squared plus 8 times -2 plus 15. 4, +15. When I type all of this in, I'm going to get the value 3. So if x is -2, then the point that I'm going to get is -2, 3. Any questions on finding this point? Okay. Now here comes a trick that is going to help you. We know we are allowed to pick any value that we want, really, technically. And so what if I let x equal 0? And I put those in right here. Square 0 plus 15. Well, this guy's just 0. This guy's just 0. It leaves me with just a 15. Also, what that means is I have the point 0, 15. When I have a point that starts out with 0, this is also the y-intercept, if we remember. A trick that I can use is anytime I want to find the y-intercept of a quadratic function that's already been written out, just pretend like this is in here and this is in here, and it's just 0, your constant. That'll work every single time. And so really, you wouldn't have to do all of this work. You could just say, oh, this will be 0, and this will be 0, and I'll be left with a 15. And so my point is 0. Sorry about that, I hit the wrong button. Okay, so now I know it opens upward. I have a vertex, I have 2 x-intercepts, and I have 2 other random points. And so now all that's left to do is to graph this thing. So let's do it, and then we'll be done. And then you can, you'll have done 2 of these problems, and you'll kind of know what to expect, and you can ask your questions. So here we go. We'll draw my graph. Okay, and a few tick marks on here so we can graph this thing. And so my vertex is -4, -1. And so I will graph that first. So I go left 4, 1, 2, 3, 4, and then I go down 1. So I got it, check. My x-intercepts are -3 and -5. So 1, 2, 3, and then 4, 5. Okay, got those 2. And then I have these 2 other points. So -2, 3. So 1, 2, 1, 2, 3. Okay. Now, this point, net 0, 15, obviously I don't have 15 up spaces, and that's okay. It's just, I just know it's going to be up here somewhere. And so the idea behind using this y-intercept is I know that it's going to get kind of steep. So I start at my vertex on the right-hand side, and I connect my dots, and then I go on my left-hand side, and I kind of mirror that same exact shape. And now I'm done. There's my problem. Now, what are your thoughts on this one from start to finish? This is the one where I had to complete the square. Okay, well, I have another one for us to try if we think we can. Do you have any questions, or are we ready to move on? Anybody still listening? All right, I'm going to take your silence as yes, we can move on. Okay, so here we go. The next one is going to look a little different, so pay close attention to how it looks and how I deal with it. So I'm going to have f of x equals negative x squared plus 4x minus 3. And so the first thing that you probably notice is, oh goodness, this is negative. And we have gone on and on and on about how we don't really want that to be negative because it makes everything way more complicated. And so the first thing that I want to do is I want to get rid of that. But I got to be careful. I can't just get rid of it. I have to work through it. And so what I'm going to do is this, okay? And this is where it's going to get a little iffy, so pay real close attention. I'm going to pull out a negative 1. But I'm only going to do that for my x values. This guy, he's fine. I don't really care what he looks like. So I'm going to put a set of parentheses here. And I'm going to say, okay, negative x divided by negative 1 is just positive x squared. And positive 4x divided by negative 1 is negative 4x. For the time being, whoops, I didn't mean to put that parenthesis. I'm going to leave a blank because I know I have to put something in there. I'm going to close off my parentheses. This negative 3 is chilling. I don't care about him. He's just hanging out there. All right, so now I'm going to go to my scrap work. And my b value in this case is still where you think it would be. So I will have negative 4. I will divide that by 2. I will get a negative 2. I will square it, and I will get a 4. Okay? And so what's going to happen now is, since this is a positive 4, I'm going to put a plus 4 here. Now, here's where it gets a little iffy, okay? And I think, Heather, you asked me this question, so specifically watch this. If I were to distribute this negative 1 to that x squared, don't you agree that it's negative x squared, which is exactly what I started with? So my problem there hasn't changed. I'm still good. Now, if I were to distribute this negative 1 and I hit on this negative 4x, that would give me a positive 4x, which is exactly what I started with. So I'm good. I haven't changed my problem so far. Well, obviously this negative 3 hasn't changed, so I'm good. Now here's what's happened. I have written a positive 4 right here. However, if I were to distribute this negative, technically negative 1 times positive 4 is a negative 4. So really what I've done to this problem so far is I have inserted a negative 4. Even though it looks like a positive, because of this negative sign out front, I have technically inserted a negative 4. And so in order for me to balance out the negative 4 that I actually put, over here somewhere I'm going to have to put a positive 4, plus 4. Now you're thinking to yourself, how can that be? Because you put a plus 4 here and a plus 4 here. But because of this negative 1 out front, and when I do the distributing, technically speaking, I actually put a negative 4 in there. So here's where I put my negative 4. Here's where I put my positive 4. And those two 4s are going to cancel each other out. And so technically my problem hasn't changed. Now, what do you think about that? Any questions or problems on that?
Okay, so the only time that we'll add is if like there's a negative in front. So the whole goal is to get the C value to cancel each other.
That is correct, yes.
Okay.
All right, now, once we have, in this problem, once we've gotten that, okay, so we've got everything set up the way that we need it to. Let me get rid of some of these lines so we can read this. We should be good. All right, so once we get everything listed out the way that we need it to be, then we're ready to take this guy out here, which is my perfect square trinomial, factor quickly using this. And so my negative sign cannot go away. Now, I'm going to get rid of this 1 because I don't really need it. I look over here. I have a negative 2 in parentheses and being squared. X is the variable they give me. Here's my -2. It's in parentheses. It's being squared. So the completing of the square is done. Now, these guys are just numbers. Well, if I have a -3 and I add 4, that just leaves me with a +1. And so right here, I have now gone and I've gotten this thing into vertex form. And so the first part of my answer, I guess, is I'm going to be looking at this. This is vertex form. Now, what are your thoughts about completing the square, getting this thing in vertex form? Okay, so then what I want to do is I want to go ahead and write down the stuff that I know. And so I am going to get rid of this so that I have my space. And this over here is where I'm going to list out my vertex. Right now, based on the fact that this sign is right here, which direction is my parabola going to open? Is it going to open up or down? Based on this negative symbol. Okay.
Down.
Yes, it's going to open down. And so then I'm looking again at this. My vertex is going to be, this looks like a -2, so I'm going to actually pull out a +2. We leave this as it is, so a +1. My vertex is 2, 1. So I know that my graph is going to look something like this. I'm going to have my vertex at 2, 1, wherever that might be, and it's going to open down. I know in my mind that that's what it's going to look like. I just got to get all the way there. All right, and so now I have everything that I need in order to continue forward. And so let me get rid of all this mess. So I've got my vertex form. Okay, so now, oh, you know what? I didn't do that. I want to leave my vertex form up here. And so what has to happen next is I need to find my x-intercepts. I want to find my x-intercepts. And so what I'm going to do is I'm going to go back to my original problem. And I'm going to set this thing equal to 0. However, again, before I do my factoring, I need this x to be positive. So I'm going to divide every single piece by -1. And that's going to give me x squared minus 4x plus 3 still equals 0. And now I'm going to factor. So I need two numbers that are going to multiply together to give me 3 and add to give me a -4. And as it turns out, they're going to be -3 and -1. And then I'm going to quickly solve and get that x is 3 and x is 1, which tells me the intercepts are 3, 0, and 1, 0. Okay, so think about that while I jot it down. So the x-intercept is 3, 0, and 1, 0. Any questions on finding those x-intercepts? Okay. So then the next thing I need to do is to find two other points. So 2 points. And I'm going to do this by choosing. And so I look up at my vertex, and since my vertex is a 2, it makes sense for me to want to choose 1 and 3. But I can't because those have already been chosen as my intercepts. And so what if I chose, oh, I don't know, 0 and something very close to that? So let me get rid of all of this. And we said that if we have our formula and it's already written out, like the ax squared plus bx plus c, it's going to be super easy for me to find the y-intercept. So if I let x equal 0, guess what? This is gone and this is gone, and I'm left with a -3. So I have the point 0, -3. That took barely any work whatsoever. So I advise that you pick that. And so there's a point, 0, 3. And so that wasn't too bad. Hold on, I'm sorry, I should be 0, -3. My writing is worse, if you can believe it, on this tablet. 0, -3. Okay, and so now I need another point. Okay, well, let's pick something that's close to 2. But again, we can't pick 0, we can't pick 1, we can't pick 3, so maybe we pick, I don't know, 4. So let's let x equal 4. So I'm going to have the opposite of 4 squared plus 4 times 4 minus 3. Well, the opposite sign stays. 4 squared is 16. 4 times 4 is positive 16, and I still have a minus 3. 16's cancel, leaves me with a -3. And so the second point that I get is 4, -3. And so now after all of this work, I have all of these points, and I'm ready to go. So what are your thoughts so far? So the new part really was the fact that I had to complete the square, and I had to get the negative out. Any questions, any problems on what I've done so far? Because if not, I'm about to graph this thing. Then we'll be done. here's my graph. And the first thing I want to do is graph my vertex, which is 2, 1. And so I start at the origin, I go over 2, I go up 1. Okay, there's my vertex, check. Then I want to graph my 2 x-intercepts, which is 1, 0, and 3, 0. Okay, check, check, got it. The two other points that I have is 0, negative 3. So I start at the origin, I go down 3. And then 4, negative 3. So I go to the right 4 and I go down 3. Okay. And from the get-go, we knew this thing was going to open downward. So I'm going to draw my smooth curve, the best that I can. And now I'm done. All right, what do you guys think? Questions, problems? Okay. So I have one more that I want to show you. We're not going to do the whole thing. I just want to show you the beginning so that you don't freak out when you come across it. And then we'll be done with the 4.2a notes. And then the 4.2b notes are not very important. Okay, so here we go. So this will be the last one we do on this section. And we're going to have f of x equals x squared plus 5x plus 6. And again, what I'm trying to do here is I'm trying to go from a quadratic function to vertex solve. And in order for me to do that, I'm going to have to complete the square. So I'm going to say, okay, well, this is going to be x squared plus 5x. I'm going to leave space. I'm going to put that in parentheses, and my plus 6 is going to be out here. Here's my scratch work. I take my b value, which in this case is a 5. I divide by 2. Darn, it doesn't divide evenly. I still have 5 halves. Well, we talked about this before. We said, even if it doesn't divide evenly, I don't want a decimal. And so I'm just going to leave it as the fraction 5 halves, even though it looks weird. And then when I go to square this, I don't need my calculator. I'm going to square the top, 25. I'm going to square the bottom, 4. So I have 25 fourths. And so what I'm going to do is I'm going to put plus 25 fourths here. And so technically I have added 25 fourths to the inside of the parentheses. And so the opposite of adding 25 fourths is subtracting 25 fourths. So I'm going to be subtracting 25 fourths from the outside of the parentheses. And so now this is my perfect square trinomial. And I can quickly factor it by looking over here. This is a positive 5 halves. It's in parentheses and it's being squared. So here's my x, here's my positive 5 halves, here's my parentheses, here's my square. And so then I'm going to say, all right, these are just numbers. So in my calculator, I'll type 6 plus parentheses, the number negative 25, divided by 4, and then I'll hit enter. And then somewhere on your calculator, you probably have your F to B button. I'm not sure, but I don't want a decimal. I want it as a fraction. And so when you type that in, you hit enter, you're going to get negative 1. You're going to get negative 1/4. And this will be your vertex form. Even though there's fractions, that's okay. We're still going to do it the same way. And so we would look at this and we would say, okay, well, what's my vertex? Well, we look inside. This looks like a positive 5 halves. So we write it out as a negative 5 halves. And then we take this little guy for face value, negative 1/4. And there's my vertex. And then from here, you can continue to find your x-intercepts by setting this equal to 0, solving. You could find your 2 other points and you could graph. I don't want to go any further because I want to make sure that we're dealing with our time. But the point of this particular problem is that even though you have a fraction, okay, even though you have these nasty looking fractions, it's all right. We'll still do it the exact same way. We get our vertex form, we get our vertex, and we go about life. What are your questions on this one? Questions and problems? We're done 4.8. So that's the conclusion of 4.2a. And like I had mentioned before, these notes these notes are already going to be in Blackboard for you. So in case you missed something or you didn't write it all down or whatever. But we are going to just dive right into section 4.2b. And in this section, we're still talking about quadratic functions. We're still talking about vertex. However, we're talking about max and min functions. Okay, max and min just means the most or the least. That's it. And we're still using our quadratic functions. Oops, quadratic functions. Okay. And so the thing that we have to be able to visualize in our head is when we talk about a maximum, when we talk about a minimum, those are just points that are found on a parabola. And every time we see or we hear about a maximum or a minimum, that's just the vertex. And so there are two things that need to be able to come to our mind in this section. If we have a parabola, let's say it looks like this. It's opening downward. This particular point is the vertex. It also happens to be, in this case, the maximum. It's the highest point on this whole entire thing. Well, on the other hand, maybe we have a parabola that looks something like this. It opens upward. Well, in this case, this guy right over here, this is still my vertex, but in this instance, he happens to be the minimum. He is the lowest point on this parabola. So when we do these problems, max and min problems, a lot of them, most of them are going to be word problems, and that's okay. But what we have to realize is even though it's a word problem, somewhere out there in Graphland, we have one of these two options. And we're either going to be searching for a maximum or a minimum, but either way, regardless of what I'm looking for, technically I'm looking for the vertex. Okay, and the cool thing about the fact that I'm going to be looking for a vertex, there's a formula that I'm about to give you that will let us find the vertex every single time. Before I swap the page, any questions on these two pictures? Okay, so then let's take a look and let's see what happens when we find the vertex. So this is okay, we're going to use it all the time. Here's what it says. It says the opposite comma, and then I have f parentheses, the opposite of b over 2a. This whole entire thing is actually written as an ordered pair. This first bit is my x value. All of this second bit is my y value. Now you're like, what does this mean? Okay, let me keep going. And then when we do a problem, I think it'll make it clear. Go ahead.
Is that an F?
It is an f, yes. This says f of the opposite of b over 2a. And so what's going to happen is we are going to have two separate pieces. All of this is going to be equivalent to my x value. And then all of this is going to be equivalent to my y value. So what we need to know from this is in our word problems, we're not going to see any of this. Our word problems are going to have just that. They're going to have words. And so when we see that there's two phrases that we're looking for, our x value is going to tell us, so x tells us how many. So some of the questions are going to say, hey, how many votes do you need to produce so that you make the most amount of money? Well, if it's asking me for how many, I only need to calculate my x value. Okay, and once we do a problem, this will kind of bring it home. But you gotta let me get there first. Now, on the other hand, there will be some questions. Our y value will tell us how much. Okay, and so there will be some questions that say, oh, how much money? Blah blah blah. Or some questions that say how many. And so when we read through that, that's gonna be the first thing we look for. We're gonna look for one of these phrases: how much or how many. Once we find that, we're going to say, oh, because it says how many, I only need to find my x value. Because it says how much, I need to find my y value. Okay, and so what's going to happen is, it's going to be super easy to do that. Take the function, and we're going to pluck it apart, and we're going to fill it in with using the opposite of RB divided by 2 times RA. We're going to get a number. Okay, we don't know what this is going to be, but this x is going to produce some type of a number. If I have to find my y value, I'm going to take the number that my x value gave me, and I'm going to put it inside the function. So whatever function I've been given, which you'll see in just a moment, I'll take that value of x, whatever it happens to be, I will plug it into my entire function, I will evaluate, and that will tell me how much. And I know this is confusing, and I know we've never done this before. You probably have never seen this before, but we're going to make that just much more clearer on the next problem. So, before we dive into an actual problem with actual words, are there any questions on what this is saying? I know it's not clear yet, but before I actually go about it, any questions on the words? Okay, so here we go. We're going to do an actual problem. So the first one that we're going to do is this. We're going to be given this function, r of x, 300 minus 5x squared. And in this function, I know that x is the number of hotel rooms that a certain hotel has booked for the weekend. Now here's the question that we're actually trying to solve. The question is, how many rooms booked produce the max amount of money? That's my question. So take a second, think about this. We're given a function. We know that in that function, x is the number of hotel rooms that's booked. My question to you is, how many hotel rooms do I need to book? Meaning I own the hotel, not that I'm a visitor. How many hotel rooms in my hotel need to be booked so that I can produce the most amount of money? Well, the first thing that we have to do is I need to read through this problem and I need to look for the phrase how many or how much. And so I see that. I see the phrase how many right here. And so because of that, because I see how many, I know that I need only the x value. And so then if I think back, I know that with vertex formula, the x value is equal to the opposite of b over 2a. That's given to me in the formula. So that's nothing that I have to come up with on my own. And so in order for me to do this, I need to take my function, which is this guy right here, and I need to find my a and my b. Now here's the problem with this guy. He's written in reverse. We know that my a value is the value that always is squared. In this particular case, it's reversed. So my advice to you is to always rewrite your function in degree descending order every single time. So r of x is going to equal negative 0.25x squared plus 300x every time. Rewrite it. And so since I only need this x value, I know that this is my a and this is my b. And so I'm going to say, okay, well, x is going to equal, and I will take the opposite of my b. My b is a positive 300, so the opposite of that is a negative 300. I will divide it by the number 2. The value of my a is negative 0.25. So now I have an equation that I can actually evaluate. For the time being, negative 300 is going to have to stay the same. I want you to do this on the bottom first, type it into your calculator first. So you're going to type 2 times negative 0.25, and that's going to equal negative 0.5. And now this is just a division problem. Negative 300 divided by negative 0.5. When you type that in your calculator, you're going to get the number 600. The question I ask you is how many hotel rooms booked produce the maximum amount of money? Well, when you get this answer 600, that tells me how many. Well, how many what? You're going to write hotel rooms. And now we're done. 600 hotel rooms is going to produce for me the most amount of money. Done. Okay, what are your thoughts on this one? Okay, I'm going to take your silence as it's all good. We're going to move on. If you have something, you can chime in right now. Okay. So then let's look at a problem. That's going to look a little different, and we're going to have to find the y value, okay, because of course that will be done differently. So here we go. So we're going to have, we're going to be given a revenue function, which revenue just means money, okay? So revenue function, and it's going to look like this. It's going to be r of x equals x times px. P of x. The problem is going to go on to say, and P of x equals 700 minus 0.4x. Here's the question. We need to find how much max revenue actually is. So we're looking for the actual amount of money, how much max revenue is. There's my question. I'm given this revenue function. And I'm also given another function, which we'll talk about in a moment. But the question actually asks me how much. So because I see the phrase how much, I know that I am going to need the y value. Well, in this case, my x value I know is the opposite of b over 2a. My y value is f of the opposite of b over 2a. So even though I need the y value as my final answer, I'm still going to have to find the x value first. And so what I'm going to have to do is I'm going to have to take into consideration these two formulas, these two functions. I know that my big function, my big revenue function is x times p of x. However, I know what p of x is. And so I can take what p of x is and I can get rid of this stuff. And so I can take these two functions and I can combine them. And that's going to give me r of x equals x times, and in parentheses, instead of me writing p of x like the original problem, I'm going to write what p of x is. So 700 minus 0.4x. Now I know in order to get rid of parentheses, I'm going to have to distribute. And so I'm going to get 700x minus 0.4x squared. But again, my advice to you is write this in degree descending order. So we're going to have r of x equals negative 0.4x squared plus 700x. So this guy down here is the formula that I'm going to use. Everything else that I have written right now, I don't really care about. So before I do anything else, are there any questions on how I got this guy right here? Okay, so I'm going to erase some of this stuff so that we have plenty of room to work. And so again, since the question is asking me how much, I know that my final answer is going to be my y value. However, I cannot just get the y value. I have to get the x value first, and then I have to use that to come up with the y value. So here's what I'm going to do. Okay, I'm going to do this in two parts. I'm going to find the x value first by using this part, the opposite of b over 2a. So in this case, here's my a and here's my b. And so when I go to find my x value, I know that the opposite of my b is going to be negative 700. I'm going to divide that by the number 2 times my a value, which is negative 0.4. So for the time being, negative 700 stays the same. And then in my calculator, I do 2 times negative 0.4, which gives me negative 0.8. And then what I'm able to do is now divide negative 700 divided by negative 0.8. That's going to give me 875. So 875 is my x value. So there's part of my answer. Okay, I just figured out my x value. But that's not my whole answer. Okay, I need how much money. Not how many, but how much money. And so once I have the x value, what this says right here, f of, just means instead of the opposite of b over 2a, I figured that was actually equal to 875. And so instead of me coming up and doing f of negative opposite of b over 2a, I'm going to stick in that place in 875. So in my original function, everywhere I see an x, I'm putting an 875 instead. And so what I'll do is, in order for me to find my y value, is I will say r of 875 squared plus 700 times 875. And then I will type all of this into my calculator as one. And so what will happen is when I do that, I'm going to get the number. It's going to be a big number, 306,250. Now the question was, how much is the max revenue? So since I'm talking about dollars, I'm going to put a dollar sign in front of this guy, and here's my final answer. The maximum revenue that I can get from whatever it is I'm trying to do is $306,250. Now, I'm totally done. This is my final answer. So what are your thoughts? We're completely and totally done with this guy. We took two equations, we combined them to make one, we found the x value. Once we found that number, we plugged it back into our original function, we calculated that, we found our y value. In this case, the y value is my answer. Questions or problems? All right, then I have one more question to go, and I'd like you to hang around for maybe 5 more minutes while we do it, and then we'll be done, okay? So here we go. and it's another max min problem. Okay, so this one we have to actually draw a picture first. Okay, so here's what we're gonna do. I'm a farmer now, apparently, and on my free time I farm. And what I'm trying to do is I'm trying to build a goat pen, and I'm trying to make it as big as I possibly can. And so here's the like the setup. I have a creek that runs on my property like this. And so what I want to do is I want to take my fence and I want to make a pen, but I want to use the creek as one side. So this is the creek. Okay. So what that means is I have to build a fence, and it has to be on this side, and this side, and this side. And the goal is for me to create this rectangular pen. And I know I need it to be a rectangle because I want it to be the same size on both sides. And so what happens is, the rest of the problem is, in order for me to make this pen, I have 620 feet of fence that I'm going to use. And so what has to happen is I have to put fence here, and I have to put fence here, and I have to put fence here. I do not have to put fence on the creek, which is good because I saved some fence there. And so my question is, the question that I'm actually trying to answer is, how much is the max area of this pen? That's the actual question. How much is the maximum area of this pen? So really, I can make a pen that's really narrow and really long. That could be one option. Maybe I make a pen that's super fat and super skinny. I don't know. So what I'm trying to figure out is just that. I'm trying to figure out how I need to make this pen so that it can have the most amount of area. Well, that's it. So before I do anything, what are your thoughts? Here's my picture. Here's my question. Any problems so far? Okay. All right, we're almost done. Okay, so I know that I have 620 feet of fence to start with. The cool thing about a rectangle is I know that these two sides are the exact same size because that's the rules of rectangle. Well, if I call this side X and I call this side X, and I've got my 620 square feet of fence, I've taken 620 and I've subtracted this X. I've also subtracted this X. Well, how much do I have left? Well, I don't know because I don't know what X is. However, what I do know is that the length of this side is going to be 620 minus the 2x that I've already used. So now I know at least, kind of how long the sides are going to be. This guy's x, this guy's 620 minus 2x, and this guy's x. Now here's the other thing I need to know. When I am finding the area of a rectangle, it's length times width. And so here is the length and here is the width. So I'm going to write this function, a of x equals the length, 620 minus 2x times the width, x. Now I also know that I can't have all these parentheses, so I'm going to have to do some distributing. So I'm going to get 620x minus 2x squared. Well, I want my function to be written in degree descending order. So I'm going to flip this thing around and say that a of x is negative 2x squared plus 620x. Now, all the work that I've done so far has led me to this particular function. And this little guy right here, this is the function that I'm going to use. Now, since I'm asking how many, what I really need is the y value. So I'm going to do exactly what I did in the last problem. But before I do that, because that's going to be the easy part, before I do that, are there any questions or problems on the setup of this particular example? I drew my picture. I said, hey, I need to know the area. I wrote that out. I distributed. I rewrote my function in degree descending. Any questions, any problems on that right now? All right, so then I'm going to erase some of this so that we have space, and then we're going to solve it, and then we will be done. Okay? All right, so what's going to happen is I'm going to use the vertex formula, which again, I will give to you. You don't have to memorize it. You just have to know how to use it. And we are going to find our x value first. So when we find the x value, we know that it is, so the vertex formula is opposite of the opposite. All right, so here we go, real quick. My a value is a negative 2, my b value is a 620. So the opposite of my b value is negative 620. I'm going to divide that by the number 2 times my a value. 620, negative 620 stays the same on the top. I multiply the bottom first, I get a -4. When I do that division, I get 155. So I know that x equals 155. So that's good. Okay, that's super good. And so what I can do is I can get rid of this, and it's no longer all this nasty stuff. It's just the number 155. Now, when I go to find my y value, I can get rid of all this nasty stuff, and I can just say, hey, it's f of 155. And so what happens is, in my x, or in my formula, everywhere I see the value x, I'm going to replace it with a 155. And so in order for me to solve my y value, I'm going to have a of 155 -2 155 squared plus 620 times 155. And then again, I'm going to type this entire thing into my calculator all at once. And when I do that, I'm going to get a of 155 equals 48050. Now, since I'm asking you how much area, we're talking about feet, okay, because that's the length of my fence and whatnot. So we're going to throw a comment in here. I'm going to write square feet, and this is going to be my final answer. And so using all this information, basically what I'm saying is I put the goat pen, which is 48,050 square feet. Okay, and I know the logistics don't seem right because who's going to make a goat pen that big? Okay, but remember, these are made up problems. This is my final answer. Any questions, any problems? I'm getting there. Okay. So as far as the section 4.2 goes, those are it. Those are the notes. If you look in Blackboard, I'm in the process of uploading the notes and uploading my videos. I had a little hiccup overnight. It didn't work. And there's also the section 4.1/4.2 assignment. And that's the one that you're going to have to write down on your paper and that you're going to have to scan in for me. So make sure that we can do that. And you have a couple of days in order to get that done. And you also have to remember that your Hawks is also, you're still working on that. Okay. Some people have dropped the ball on that, so we can't let that happen. So I'm done. Before you guys go, are there any questions or problems that you have? Just chime in now or type. I can see the screen now, so if you want to type something to me, go right ahead. Otherwise, I'm done. So if you're good, I'm good. You need to go ahead, and we'll talk again tomorrow. So if you want to hang back and ask me something, okay. So I'll see you guys tomorrow. Have a good day. Otherwise, stay and ask me.